Hello friends, welcome to another video in filter realization. In this video we'll talk about the lattice structure realization of FIR filter. An FIR filter will look something like this. It is an all zeros function and the transfer function is h of z. It is given like this. And I highly recommend that you watch my previous video on the lattice structure realization of FIR filter, where I talk about the formulas and the structure needed for the filter realization in lattice structure. However, I'm going to discuss that here also, but I'll go through it very quickly. The structure that needs to be remembered is exactly opposite to that of IIR. In IIR, all the summing elements were in the opposite direction to the delay elements. They were coming prior to the delay elements. Here they are coming after the delay elements, and the coefficients are not inverted in signs. So that's the two things that you need to remember. So you need to draw this structure like this with 3 delay elements, each of them followed by the summing elements, and the coefficients crisscrossing, progressing from k1, k2 and k3. The reason we have drawn 3 delay elements is because we have a total of z minus 3 in the question equation. So the steps are pretty simple. Find k1, k2, k3, substitute it here, and you're done. And the formulas to remember, again, it is similar to that of the IIR filter. You need to find A3, A2 and A1. From A3 you can easily find K3, from A2 you can find K2, and from A1 you can find K1. And what is A3? You can find A3 from the questions, as I mentioned in the previous video. So A3 is nothing but this h of z here. So this entire long equation, this is A3, and out of this equation this part is K3. As I mentioned previously, the coefficient of the highest negative power is K3. And now that you know A3, you can find B3. Alright. So A3 is this, and K3 is the highest power coefficient, which is 1 by 4. So K3 is known, A3 is known, you need to find out B3 now. And A2 is, I'm directly finding A2 by substituting A3 and B3. And I told you the trick in the previous video that B3 can be found by reversing the coefficients of A3. So if this is 1, 3, 4, 1 by 2, 1 by 4, so I can make it 1 by 4, 1 by 4, 1 by 2 and 1. And K3 was 1 by 4, so this is 1 by 16. So my A2 becomes this, and the coefficient of the highest power is K2. So I'm done with K3s here and K2s here. So I'm left with K1. For that I need to find A1. So A1z is A2z minus K2b2z 1 minus K2 square, and substituting the value of A2 and B2 is coefficient reversed, and I can find A1. A1 is 1 plus half z minus, and half is K1. Now substituting K1, K2 and K3 in the structure, we get answer like this. So there is no negative sign here in the upward direction as we had in the IIR filter. So FIR filters are much more easier to realize, and I hope you liked the video. If you did, give it a thumbs up. I'll see you around.